Welcome back, everybody. Today's kind of a unique post. For my class, we go over polar coordinates kind of as a review section in conjunction with cylindrical coordinates, so bringing it from 2 dimensions to 3 dimensions. So I'm going to make this video. I'm posting it in the Calc 3 video list, but I'm also going to cross-post it into pre-calculus. That way, anyone studying pre-calculus who needs to deal with polar coordinates is certainly welcome to it. In the calculus textbook that we use for my class, it is in Appendix H. All right. So, the first thing we need to know is that the polar axis is the positive x-axis. All right, so we will term that the polar axis. And in rectangular coordinates, right, location of a point is determined by horizontal and vertical distance. However, in polar coordinates, r might be your directed distance, but theta is the angle that starts at the polar axis here and goes until you get to the desired point. Let's talk about some similarities and differences between polar and rectangular coordinates. In polar and rectangular, 0, 0 is a unique point. However, in polar it is called the pole. In rectangular it is called the origin. Coordinates are in the form of r theta for polar. Coordinates are in the form of xy for rectangular. One key difference that we have is that our grids are different. In rectangular grid, we go horizontal, vertical. With polar, we utilize an angle, so we'll move swiftly through an angle. All right, so let's talk about plotting points. For those that have never plotted points before, this is going to be a helpful section. All right, so here I have 4 points. Let's plot them. So the first is 3 comma 5 pi over 3. So what I'm going to do is I'm going to start here at the origin. I'm going to use markings because we're not using a board, you can't see me. And I'm going to go out 3. So notice here I've got 1, I got 2, I got 3. So I'm going out to 3, and then I'm going to rotate at an angle of 5 pi over 3. So I'm going to rotate this way until I get to 5 pi over 3, which lands me right here. And that would be the only marking that I would need to signify that particular point. Now for the next one, 2 comma negative pi over 4. Again, actually, you know what? Let me try using the highlighter or the laser pointer. Let's see how that works. I'm going to go out to 2, and then I'm going to rotate down clockwise. If you remember in your unit circle, positive angles went counterclockwise, negative angles went clockwise. So I'm going to go down pi over 4. So I'm just going down to here. And now I'm going to change over to my pen, and I'm going to plot that particular point. 3 comma 0. So I'm going to start at the pole, and I'm going to go out 3, and my angle says I'm going to go up 0. So I'm going to plot my point right here. And negative 2 comma pi over 4. I've seen a few different texts do this a couple of different ways. I'm going to show you how I like to do it. So I'm going to start at the pole once again. I'm going to go to the left 2, so there's my negative 2 right here. And then I'm going to go positive pi over 4, which means counterclockwise, pi over 4 units. So I'm at pi, right? So I need to rotate until I get to 5 pi over 4. So I'm going to switch back to my pen, and I'm going to place the dot right there. So there's just a little bit of a review on how to plot some points. I would definitely encourage, if you need a little bit more practice, to definitely work through a few more. Now, one interesting thing about polar coordinates that is not available in rectangular coordinates is that there are a multitude of different number names for the same location. For example, if we have 2 comma pi over 4, which we said before was right here, right? I can add 2 pi to my angle. I get 2 comma 9 pi over 4, And if we graph that particular point, what you'll notice is we wind up in the same spot. Or I can graph 2 comma negative 7 pi over 4. And once again, we graph that point, we wind up in the same spot. So there are indeed a multitude of different number names that we can use in order to signify a single location. All right, and there is negative 2 comma 5 pi over 4, which again would put us in the same spot. All right, so here's an example. 3 comma pi over 6, right, which if you'll notice, I'm going to use my laser pointer, puts us right over here, right? Now the question is, give me 3 other number names that satisfy the given conditions. The first condition says r is greater than 0, theta is between 2 pi and 4 pi. For B, it says r is less than 0, theta is between 0 and 2 pi. For C, it's r is greater than 0, but theta is between negative 2 pi and 0. All right, so what are we going to do? Well, for A and C, we have a positive r. So like, for example, for A, r is still going to equal 3. But what I'm going to do is I'm going to add 2 pi to pi over 6. So I have pi over 6 plus 2 pi. And it winds up being 13 pi over 6. So my answer there, would be 3 comma 13 pi over 6. Now for B, the interesting thing is we need a negative r. Well, if we're going to go, we have to land out 3 units from the pole, and we need negative r. I'm going to say that r, it's going to be a pretty safe bet that r is going to equal negative 3. Now the question is, right, if I'm going out negative 3 units on my r, then how far do I have to go in order to wind up right there? Well, if I go from pi to 2 pi, that's 6 pi over 6. So I have to go an extra. So I have to go 7 pi over 6. So negative 3 comma 7 pi over 6 would be the second number name. Now for the third one, again, we have a positive r, so r equals 3, and I just have to subtract 2 pi from my angle. So I have pi over 6 minus 2 pi, and that equals negative 11 pi over 6. So my answer again would be 3 comma negative 11 pi over 6, which would take us in this direction. Not quite all the way around, but most of the way around. All right. All right. So let's continue. All right. So the next thing we need to do is talk about how to convert from polar to rectangular coordinates. Now for this, we need to start with some conversion equations. So we're going to use these. X equals r cosine theta, y equals r sine theta. There is some math to show you how to derive these. I'm not doing it at this point in an effort to keep the video short. But write these down because we'll use them in our first example. All right, so our first example is 6 comma pi over 6. So we're going to use our x equals r cosine theta. R is 6, and then we need the cosine of pi over 6. That's a terrible 6. I'm going to make that a little bit better. Now, the key here is you definitely need to know your unit circle. All right. So we have 6, excuse me, I'm getting ahead of myself. We have 6 times, and the cosine of pi over 6 is radical 3 over 2, and that winds up equaling 3 radical 3. For y, it equals r sine theta, which equals 6 times sine of pi over 6. So again, you need to know your unit circle. So I have 6, and what's the sine of pi over 6 is positive 1/2, which equals 3. So the conversion from 6 comma pi over 6 to rectangular coordinates would be 3 radical 3 comma 3. And I always say the best way to do this is to kind of just check the quadrant that you're in. 6 comma pi over 6 would be in the first quadrant. 3 radical 3 comma 3, since they're both positive, would be in the first quadrant. Not to say it's a guarantee that you're right, but it is a strong indicator that you've done some good work. All right. So now for B, we have negative 4 comma negative pi over 4. Now that particular point, polar rectangular, should be in quadrant 4. So basically what we need to know is, in rectangular, does our point wind up in the right quadrant? So I have, sorry, hang on. X equals negative 4 cosine negative pi over 4, which equals negative 4 radical 2 over 2, which equals negative 2 radical 2, and y equals r sine theta. So r is negative 4, and then it's sine negative pi over 4, which equals negative 4. And the sign of negative pi over 4 is in quadrant 4. And that is, since it's the y value, would be negative. So negative radical 2 over 2, which equals 2 radical 2. So our answer is going to be negative 2 radical 2, 2 radical 2, which I think I said quadrant 4 before, but really is quadrant 2, and that matches with what we were saying before. So my apologies if I misspoke. All right. So now we have done from polar to rectangular. So now we need to do from rectangular to polar. All right. So we have these points. Now we need our conversion equations. All right. So, well, the first thing we'll do is we'll show the graph. And we show the graph is in quadrant 3. And what we hope is that when we get our polar coordinates, that those polar coordinates wind up in quadrant 3. All right, so, excuse me. So next thing we need is our conversion equations. So we have two other conversion equations. We have r squared equals x squared plus y squared, or r equals the square root of x squared plus y squared. We also have tangent theta equals y over x, or you can say arctan y over x equals theta. So we're going to use these conversion equations to our advantage because we have an x and a y, not an r and a theta just yet. So for this one, I have r equals the square root of 1 squared plus radical 3 squared, which equals the square root of 1 plus 3, which equals the square root of 4, which equals 2. And now we got to look at our arctan of negative radical 3 over negative 1 is just radical 3. And again, you need to know your unit circle, so that would equal pi over 3. So I have the answer of 2 comma pi over 3. Now the only problem with that is 2 comma pi over 3 gets me into quadrant 1, like right about here. What I really need is I need to be in quadrant 3 down here. So how am I going to get there? Well, I got to adjust my angle. What I can do is if I add pi to my angle, I go from quadrant 1 to quadrant 3, and I'm in the correct location. So my actual answer would be 2 comma 4 pi over 3. Okay, 2 comma 4 pi over 3. All right. Now I want to, okay, so here is one more. I want to talk about this one because this one, again, we have to use our conversion equations. Now I put the conversion equations at the bottom, so I'm not going to rewrite them. I'm just going to go straight to it. R equals the square root of negative 2 squared all right, so at this point, why don't you pause the video and do a little algebra and then start it up again, and we'll see if we're on the same page. So go ahead, pause the video, and do the math. All right, hopefully you paused the video and worked it out. So this should be 4. And I have tangent of theta equals y over x, which would wind up being negative radical 3. So theta would equal, I got negative pi over 3, even though my pen doesn't seem to want to write today. The key is, now this is going to bring us into quadrant 4. However, our point was in quadrant 2, right? This point up here. So I need to, once again, add pi to get myself into the right spot. So my actual final answer would be 4 comma 2 pi over 3. All right. Now let's go equations between polar and rectangular. So here is a rectangular equation. And I want to use the same conversions that I used before. So I'm not going to do anything different. So I'm going to, right, every time I see an x, I'm going to put in an r cosine theta. Every time I see a y, I'm going to put in an r sine theta. All right. So at this point, I'm going to have you pause the video. And I want you to do a little algebra for me. Now, be on the lookout. There is a trig identity that's going to be hidden in there. It's going to be cosine squared theta plus sine squared theta equals 1. All right, so I want you to use that as well. And start the video when you're ready, and we'll see if we both get the same thing. All right, hopefully you pause the video. Now I'm going to bring you down. I'm going to skip ahead a little bit. So I have r squared cosine squared theta plus sine squared theta. Hopefully you can see how hopefully you got this far. Minus 3r cosine theta plus 4 equals 0. Now if I use that, I can wind up with, use that identity, r squared minus 3r cosine theta plus 4 equals 0. Now, once I have eliminated all of my x's and y's and replaced them all with r's and thetas, I'm done. So there's not necessarily anything more you need to do with this. All right. So let's take a look. Now I want to transform from polar to rectangular. So the first one I have is r equals 3. And again, I want to use the same equations I used before. This is a little harder because you kind of have to think outside the box just a little bit. It's not just a straight substitution necessarily. So here I probably would just say like r squared equals 9. Now it's a straight substitution because r squared equals x squared plus y squared. So you wind up with x squared plus y squared equals 9. And you have converted back to rectangular. All right, so let's take a look at another one. I have theta equals 45 degrees. Now again, not such a clear, just straight substitution. I want to take the tangent of both sides. So I have tangent of theta equals tangent of 45 degrees. Now I know the tangent of 45 degrees is 1. I also know that tangent of theta equals y over x. So I'm going to do a straight substitution here. I got y over x equals 1. I can multiply both sides times x, and I get y equals x. And I have converted. For the third one, and this one will be a little bit outside the box, but it's still a pretty small one. I got r equals cosecant theta. A little outside the box because we haven't even brought up the idea of cosecant yet. But we do have an identity that's going to help us. So I have r equals 1 over sine theta. You might remember that identity from when you did trig. Now I'm going to multiply both sides times sine theta, and I wind up with r sine theta equals 1, and r sine theta equals y, so I wind up with y equals 1. All right, so basically, you know, it's kind of one of those things where you just have to think about it, think about your conversion equations and kind of what fits. But there isn't necessarily one specific way to do this. All right, so the last thing we're going to talk about a little bit is sketching a graph. All right, so basically sketching a graph involves getting a series of points. All right, so here is a particular graph of a polar equation. 2 times 1 plus cosine theta. Now, what we're going to note is that cosine theta is symmetric around the polar axis. So we're only going to compute half the graph. If you want to compute the other half of the graph, you're certainly welcome to. Or you can utilize symmetry to just get a mirror point across the polar axis. But basically what you're going to do to start this off is you're just going to, just like with x and y points, where you made an xy chart, we're going to make an r theta chart. Oop, excuse me. There we go. All right, so for our first one, I'm going to fill in thetas for you. When you practice graphing, please realize that any theta you pick is legal. It's just a matter of if your r comes out to be something that's relatively graphable. If you wind up with the decimal, I mean, you have to estimate to the best of your ability. Just remember that typical graphs that you're going to get starting off are going to be relatively smooth curves. So just keep that in mind when you're doing this. I'm going to give you thetas right now just to help out. So I give you 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. I'll make that a little bit of a better 3. 5 pi over 6. And pi. And like I said, this is going to wind up being about half your graph. So why don't you guys at this point pause the video. You're going to take each theta, you're going to plug it into the equation, and you'll work out what each individual r is going to be. All right, so pause the video, work out what each individual r is, and I'll give you the answers on the back end. See you soon. All right. Hopefully you guys pause the video to work out each individual r. So if I plug in 0, I got, excuse me. There we go. 4. And in the next one, I got 2 plus radical 3. Now, radical 3 I can estimate as 1.73. That is an acceptable estimate. So I can say it's going to be about 3.73. And again, I think I can estimate that pretty good on a graph. For pi over 3, I got just 3. For pi over 2, I got 2. For 2 pi over 3, I got 1. Now for 5 pi over 6, I got 2 minus radical 3. So again, I'm going to use the same estimate, 1.73, and I get 0.27. And for pi, I got 0. All right. So this is going to be, again, half your graph. So let's take a look at what it looks like. So what we did was we made a chart for the red part of the graph. Now the blue part, again, is going to be the reflection. So each point that you made has a reflection across our polar axis. If you wanted to make a chart for negative pi over 6, negative pi over 3, negative pi over 2, so on and so forth, you're certainly welcome to. There's nothing wrong with that. All right. Graphing ultimately just takes practice. This particular graph is called a cardioid because it resembles a human heart. But like I said, once you start practicing, all of a sudden graphing becomes just a little bit more fluent. All right. Well, I hope you enjoyed just a little bit of a refresher on polar coordinates. I definitely encourage you to practice more, but I will see you again next time. Thanks, guys. See you soon.